it. So it will get opened and we'll start our session. Okay. So let me see how many of you are there. So 11. So still two, three people are just again, I'm waiting for them. So before that, if you want to ask me any question, you can have that within 2 or 3 minutes. We'll just chat into it. Yes. Anybody having any problem till whatever we have seen? Yes. I think you nobody has any problem. So shall I move to the session? Hello.
Excuse me, sir.
Yeah.
Yes, sir.
We'll start it. Yeah. Suleka ji wants to say something. Yes.
Yes, sir.
Hello.
In roofs. Yes, sir. Can you
Yeah.
hear me?
Yeah. I can hear you. Yes.
Okay, sir. Okay. So in the roof slab, how we should apply any water tank or any AC machineries if we have in the roof. So how we will apply the load for this?
Okay. Okay. That's okay. I will shift it to that session and see here. If you want to apply the loading of the water tank, there are two ways. Uh, So let us go to plan and terrace. So I'm opening the terrace floor plan, and here you have to find out on which level or what is the plan dimension of your water tank. Mostly it is above the staircase. So you have to find out the staircase and that portion. Either let's say you are having a water tank on this portion. Okay, so there are two ways. Either you can create a water tank model in ETAB itself, and then you can apply the loading uh, uh, due to the storage of water tank on the slab, and you can apply the lateral loading on the walls. That the water will apply the pressure on the surrounding walls. But that we'll see in our practical session. Right now, we'll just assume that there is no water tank. Clear? I will go with that detailing also. Don't worry about it. So we'll create a water tank above the terrace top with some 6 to 7 feet above the terrace level. So that will do it in our practical model. And there, in that case, I will explain entire process for applying water pressure on the bottom slab as well as water pressure on the side slabs. That is side walls. Okay.
Yes, sir.
Yeah. Now,
Okay, sir. Okay.
it was a question about your that machinery. So if you are going to install any machinery on the slab, uh, the total load of the machinery will be divided on the supporting columns, and you will apply the concentrated on the columns. So let's say total weight of the entire machinery is say something 1000 kilonewton, and then that 1000 kilonewton is shared by 4 columns. So every column will have a total load of 250 kilonewton on every column. So you can apply the concentrated load on the columns. So that also we can discuss if you want. But normally, uh, okay, in Indian standards, we are not providing any machinery over the terrace, or you can create the separate modeling above the terrace. So you can increase the level over there. That you can do it through this. So you can go to edit. But right now we have analyzed, so I don't want to go into that. But in practical modeling, we'll see that also. Okay. Yeah.
Okay, sir.
Now here, yeah, you will see that today's session that we are going to contribute, or we will concentrate on how to read the analysis results. Okay. So analysis results will be available only when you will apply analysis. So in this analysis, we have run the analysis, and after running the analysis, the entire results are stored. That's why the lock, you can see here a lock. Yes,
Yes, sir.
normally it is unlocked. Why that process is carried out in this software or any other software? Because when you analyze the results of that entire whatever you have done in the modeling, the results of that in terms of forces and moments are stored. And now if you want, if you do some any additional loading, that will not be reflected in your results. That's why if I go, let's say if I go to draw something, if I click on that, you can see everything is not available to me, because if I click on this, nothing will happen, because this is it is not available, because now it is locked. You cannot make any changes in your model when it is locked. And when the model will be locked after your analysis. Now if you want to make some changes, then you have to unlock the model. You can say that click on this, and you will get the warning that please note, unlocking model will delete analysis results. And then if you say okay, then the model will be unlocked. But in that case, the results will be destroyed from the respective storage that has been reserved for storing the analysis results. So you will not find any results. So here you have to check, or you have to give him confirmation whether you want to delete the results. That means if you want to make some changes in the model, then if you say okay, then the results will be destroyed, and you are free, and you will see that the model is unlocked. Let me show you that. If I click on okay, then you can see now the model, now you can see the model is unlocked. And now if I go to this, I can draw it. Yes, I can do it. Or if I go to edit, I can edit. Let's say I can replicate, or I can do anything. That means I don't have now results. So if I go in the results, let's say in analysis, or display, and if I see there are no results over here. See, the force stress diagram is not showing me anything, because it is faint. Faint means you cannot have anything in that. So that's why again you will have to analyze. So you can go to analysis, and then again run the analysis, and the analysis will be again run. It will take very less time, as the model is very small. You can see the analysis results will be stored over here. Then you can go to undeformed shape, so original shape, and now you can see again the model is locked. Okay, now if I click on display, and you can see, I can see the deformed shape, or I can see the post trace diagram, and in that I can see support, moment peer, spandrel diagram, etc., which was not available before analysis. So only after analysis I can see all these things, not before analysis. Okay, now let us say go to display and go to show tables. And in show tables, if I click on analysis, I can see the analysis, that is analysis results. And in results, I can see displacement. So every joint displacement will be I can see it over here, or I can see the story max, story average, etc. All that we'll see one by one. But let us see how to find out the results. But before that, we must understand what is the process, how we can how we can see the results. uh, okay, in that case, let me draw some figures. So I will try to draw the figures so that it will be explained properly. I think I have given it to you, or may not be. I don't remember because I'm doing the work with a lot of batches. Okay, let's see. We'll see it. See, what do you mean by results? Yes, anybody? What you are expecting from the analysis? That must be clear. Yes.
Bending moment, shear force.
Okay.
Obstacle.
You want bending moment. Then you want shear force.
Whether our design is safe.
No, yeah, see that you can consider only after design. Now here you have not designed anything. You have
Deflected shape.
yeah.
Deflected shape.
Deflection.
Okay. Good shape. Let's say deflected shape. Or deflected diagram will say, or you can say shape. Hence, anything else than that? Only bending moment and shear force will okay with you.
Axial force.
Okay, axial force. So let's say axial force. Okay. So bending moment, shear force, and axial force, and deflected shape or deflected profile. That you want to see. Okay. So this is what is confused in our mind. Okay. I will say that you are correct to certain extent, but it is not 100% correct. See, uh, let us say this is your 3D. Let's say this is your 3D element. Let's say this is your element. Okay. And I will draw it something like this. Does it look like a 3D element? Yes or no?
Yes, sir.
So,
Yes, sir.
Now, this 3D element will be acted by external forces. And how the external forces will be random. Okay, random. It may be anything like this. Or there may be a moment. There may be a moment. Okay, there may be a moment over here, a moment over here, and moment over here. So these are the moment, these are the forces, and due to that, uh, what will be the effect of all these external forces on this body? That is your analysis. That is what we are trying to analyze. Let's say this is a solid body and it is acted by the external forces, and how this body will respond to the externally applied loads, maybe in the form of moment or in the form of uh, so that is okay. I will delete this. Now let us say what are the different types of forces. You will see that force is in any direction and it is having a moment about any axis. Now, if you want to see this generalized force, let us first consider that you want it in a 2D structure. So 2D structure is contained in one plane. And that plane may be XY. Let's say this is XY. Okay. And all the forces are lying within this plane. Means it may have action something like this. It may have action something like this. Or it may have a bending which is about the axis which is perpendicular to this. So this will be Z axis, right? So that's why we say that whenever we are analyzing any 2D structure, we say that a force in X direction, a force in Y direction, and a moment about the axis which is perpendicular to plane. That's why we
XY plane.
said a plane XY, a perpendicular axis which is perpendicular to plane XY is Z. That's why we say that Z. And in our static analysis, we say that sigma fx, sigma fy, and sigma mz. If all this is equal to 0, then the body is in equilibrium. Yes? Equilibrium.
Yes,
Yes,
sir.
sir.
Now, suppose that if this is not equal to 0, what will happen? The body will move in x direction. If this is not equal to 0, then body will move in y direction. And if this is not 0, the body will rotate about
Z axis.
axis. Right?
Yes, sir.
That means equation of static equilibrium are derived from some basic concept that we say that F equal to m times acceleration, m times a. So if I say fx will be ax. In that case, as this ax is equal to 0, we say fx equal to 0. That means there is no motion in the direction of x. If similarly fy is 0, that means m into ay is 0. M into ay is 0. And what is about rotation? Then we say that it is something around that rotational moment is 0. Okay. So that's why we call this as equation of static equilibrium. So under 2D case, we are having 3 equations of equilibrium. And what will happen in 3D?
6 equations.
So this is x, this is y, and this is z. So we'll get 6 equations of equilibrium, right? And if all these 6 equations lead to 0, that means sigma f about all axis equal to 0 and sigma moment about all axis is equal to 0. So this will have 3 equations and this will have 3 equations, right? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So in case of 3D, and now our structure is in a 3D direction. That means we must get 6 equilibrium conditions at every point, right? Yes or no?
Yes, sir.
Yes, sir.
And let us see that all that. If I will draw, and please try to understand it completely so that you will not forget. And if you don't understand, please ask me. Don't assume that you will understand it later on. Right now, I will try to simplify, but if you are getting it complicated, because this is the basic concept based on what this entire 3D structure, analysis of entire 3D structure will be applied. Okay. Now let us say that I will talk about this is one axis, this is another axis, and this is third axis. Okay. Now I will follow the conventions that are used in ETABS. So this axis is called one axis. This axis is called two axis, and this axis is called three axis. So this is a local axis system. Apart from local axis system, you will also have x axis, y axis, and z axis. So this is global axis system, and this is local axis system. Okay.
Yes, sir.
This much clear?
Yes, sir.
Yes, sir.
Now we'll see that if I call this axis. So this is one plane. Okay, this is one plane. And this plane is containing, on one side it is having one axis, on another side or another edge it is having three axes. So I will call this plane as either 1-3 plane or am I
Sir,
right?
2-3 plane.
Yeah, it's a 2-3 plane. Okay, so this is a 2-3 plane, and or I will say that I can designate it as one plane, the axis which is perpendicular to this plane. Okay, clear?
Okay, sir.
Now let's see. There will be one force which is perpendicular to this plane. So that is called a normal force. So I will call it as normal force sigma 1. Clear?
Yes, sir.
Similarly, there will be this plane. This plane will be 1-3 plane, and I will call it
Perpendicular.
as 2 plane. So the normal force will be
Sigma 2.
sigma 3, sigma 2, right? And
Yes, sir.
this will be 1-2 plane, or I will call this
Sigma 3.
force sigma 3. And I'm writing it in the positive direction. Okay.
Yes, sir.
Now every plane will have a shear stress also. Now that shear stress, I will call that shear stress as tau, and it will be, this will be a shear stress, as well as this will be shear stress. And I'm showing you the positive axis. Now this stress is on plane 1 in the direction of 2. So I will call it as
Tau 1,
tau
2.
1, 2. Right? On the plane 1 in the direction of 2. Now this stress I will call as
Tau
tau
1, 3.
1, 3. Similarly, there will be one more torsional shear stress. This stress you will call as tau on the plane 2 in the direction 1. Right?
Right, sir.
Similarly, there will be one shear stress which is called as a tau on the plane 2 in the direction of 3. Okay.
Okay, sir.
Similarly, there will be one more stress on the plane 3, that is tau 3 in the direction of 1.
3 1.
And there will be one more stress tau on the plane 3
3
in the
2.
direction 2. Okay.
Yes, sir.
Now under all, how many forces are now, how many stresses or forces are there?
9.
3 normal and 6
Torsional.
shear.
Shear.
Not torsional, 6 shear. So you will see that if this entire 3D structure has to be in equilibrium, you will say that sigma 1, sigma 2,
Sigma 3.
and sigma 3, they have to be 0. Right?
Yes, sir.
Similarly, you can see that tau 1 2 is equal to tau 2 1. So I will say that only tau 1 2, because both are same. Only then it will be in equilibrium. Clear?
Yes, sir.
Yes, sir.
Similarly, tau 1 3 and tau 3 1, they are same. So I will call it as tau 1 3. And this will be tau 2 3 and tau 3 2. So I will call it as tau 2 3. So actually there are there are 9 stresses or 9 forces, and as 2 are equal, we are considering it independent will be only 6. So 6 stresses will be there, and in entire 3D structure, you will see that these are the outcome of your analysis, right?
Right, sir.
So normal force in x direction, in y direction, and in z direction, or 1, 2, 3, and shear stress as 1, 2, 1, 3, and 2, 3. If all these forces are zero, the body will be
In
under
equilibrium.
equilibrium. And now we'll see the things in our actual elements. ये तो समझ में आया?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Now we'll go to actual element. Let's say we are going for beam. So I will draw the beam, something like this. Okay, I'm drawing the beam. Okay, now actually I'm not drawing a 3D diagram in a model. I'm only drawing one line. So this is actual beam. This is a physical beam, and this physical beam is represented by one line. So this is a CG of this cross section, and this is a CG of this cross section. I will say that this is I end, and this is J end. And actually, what I have done, I have drawn a beam from this point to this point. Okay, clear? मॉडल में
Yes,
हमने ऐसे ही निकाला है ना, एक बीम ही निकाला है ना ये.
Yes,
So
sir.
this is the I, and this will be Z.
Z.
And if I say this, so this will be I, and this will be Z. Clear?
Yes, sir.
Okay.
Sir?
Now we see. Yeah.
सर एक मैं अभी जैसे ये जो अपन ई टैब में जो अपन ये मॉडल बना रहे हैं,
हम्म.
तो इसमें सिर्फ एक्सिस को जोड़ रहा है ना, इसकी जो लॉन्गिट्यूडनल एक्सिस जा रही है,
ये
जो आई
वही ये रेड लाइन.
हाँ, ये वही है ना सर?
हाँ, this is one point and this is another point. The first point I'm calling it as I end, and second point I'm calling as J end.
J point.
You can say J end. Okay.
Yes, sir.
Now this is the local axis that will be automatically defined by a tab, and it is automatically defined in such way that from I to Z, a positive one axis will be defined by a tab automatically. Clear?
Yes, sir.
Then, as it is beam, a positive 2 axis will be drawn parallel to your Z. So this is your 2 axis. So the positive direction of one axis, positive direction of 2 axis is defined in E tab automatically. As you draw one beam, these are defined automatically. Clear?
Yes, sir.
Now the positive direction of 3 axis will be defined by the anti-clockwise direction. So if I say a right hand rule, it will give me a positive direction of 3 axis. Yes?
Yes, sir.
So similarly, it will be over here. So this will be 2 axis and this will be 3 axis. Okay. Clear?
Yes,
Yes,
sir.
sir.
Now, if this beam is subjected to axial tension, then it will be shown like this. So I will call it as axial tension. Clear?
Yes, sir.
So the tensile forces, you will see axial tension will be considered positive and axial compression will be considered negative. Clear?
Yes, sir.
Sir.
Okay. Now what about shear? Shear will be in two direction. Yes. So this is called a major shear. Now the major shear force at J end, if the shear force is upward, at J end, if the shear force is upward, then it is considered as V2 and it will be positive. Clear?
Yes, sir.
And at I end, if the shear is upward, then it will be considered as V2, but it will be considered negative.
Negative.
Right? Clear? See, here it is positive, but here the upward sign is negative. And that is confusing to most of the structure engineers because we always say that either upward will be positive or downward will be positive. Right?
सर यही पूछ रहा था कि ये क्यों हुआ है, ये पॉजिटिव और ये इधर नेगेटिव क्यों हुआ है?
That is why I have explained you that this. Right?
Yes, sir.
So the positive axis, you can recollect that. So here positive was in this direction, positive was in this direction. That was about normal
Okay.
horses. But what about shear? Here shear was positive in this direction
Yes, sir.
and it was positive in this direction. That means in this direction it will be negative.
ठीक है सर.
You have to okay.
Okay, sir. Okay. ठीक है.
Now, so this is about V2. Because why it is V2? Because it is a shear in the direction of two axes. Now, if this beam is subjected to bending, either it will be subjected to sagging or it will be subjected to hogging. Let's say it is subjected to sagging, then you will have a moment something like this. Yes. And a moment on this will be something like this. And now this moment is
Yes,
about
sir.
3 axes. So you will see that M3. Clear?
Okay, sir.
Exactly. This is the convention that is applied when you will see the results in ETAP. Okay. Is this much clear?
सर ये V2 नेगेटिव कैसे लिया आपने इस वाला इस साइड?
Because I end upward is considered negative and downward is considered positive. Okay, I will explain it a bit in detail. Let's say this is my one element. Okay, so this is my I end and this is my J end. Clear?
Yes, sir.
Yes, sir.
Now, if I want to consider the faces in the longitudinal direction, how many faces I will get? This is one face
Okay.
and this is another face. Yes.
sir.
Clear? There
Yes,
will
sir.
be two
Yes, sir.
faces in the axis parallel to one,
Yes, sir.
and that will be similar to all other axes also. So top will be in the direction of two axis, bottom will be in the direction of negative two axis. Clear?
ठीक है सर.
Because every cube will have 6 surfaces,
Yes, sir.
two surfaces at both ends. Now I will call this surface as negative surface and this surface as positive surface,
Positive surface.
and I will have somewhere neutral over here. So this is my 0. On this side it is negative, on this side it is positive, because
Negative.
positive is towards the right.
Yes,
Yes.
sir.
Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now the convention is that on positive face, if the force is acting in positive direction, it will be considered positive. Okay. On negative phase, if the force is considered in negative direction, then it will be considered positive. Clear over?
Okay, sir.
So that means if downward is positive, upward is negative,
ठीक है
Okay,
सर.
sir.
because it is on negative phase. See, this is positive two axis. So I will call it as positive two axis. That means this is negative two axis. If this is positive one axis, then I will call this as negative one axis.
Negative one.
Clear?
Yes.
So you can remember as positive will be considered positive. Negative will be considered positive.
Positive.
Then positive will be considered as negative. And negative positive will be considered as negative. अब ये रूल याद रखिए.
Yes, sir.
Or you can draw the figure and you can draw I and J and positive, negative, then top will be positive, bottom will be negative, left will be negative, right will be positive for three axis, because three axis is positive in this direction.
सर
Yeah,
सर एक पूछना था, जब आपने +3 किया है,
yeah.
अगर इधर फोर्स इस +3 के अलोंग लगे तो नेगेटिव ही होगा ना सर ये, क्योंकि प्लस माइनस माइनस हो जाएगा नेगेटिव एंड पे.
नहीं. Negative face for three axis is back and this is positive. See, you have to consider in the negative and
अच्छा.
positive face.
ठीक, ये वाला पॉजिटिव फेस हो गया,
या
इसके
और ये वाला नेगेटिव हो गया.
नेगेटिव हो गया. ठीक है.
So that's why what I am saying, we call this positive
ओके सर.
negative positive is negative. Then many concept will be clear. Oh, बातें आसान हो जाए. Right now you might find it a bit difficult. Okay, that means if I draw, let's say if I draw a beam in elevation, so this is my depth. Okay, and this is my one axis, because I am drawing it in elevation. So I am saying positive 1, and this is positive 2, and my positive 3 will be over here, a point, because I am drawing it in elevation. Clear?
यस सर.
So in that case, I will say that this force will be positive and this force will be positive. Clear?
Yes, sir.
And this moment, that is moment about 3 axis, will be positive, because this will create sagging moment, right?
Hmm.
Clear over?
Yes, sir.
So if I want to see the shear force diagram, I will have to select V2. And if I want to see the bending moment diagram, I will have to select
M3.
M3. Clear? So this is for major. This is for major shear and major bending. Clear?
Yes, sir.
Now let us draw one more figure, which I will draw from the plan. So I am drawing the plan of the beam. Then I will say that this is my beam, and this is my I end, this is my J end, and I am drawing one axis like this. And as I am looking from top, I will see my 3 axis something like this. Clear?
Hmm.
I am looking from top. First I was looking from this side, but now I'm looking from top, so I will get this as my beam width, right?
Yes, sir.
Now this is my 3 axis. Now if I want to see the shear force, then this will be say in positive direction, so this will be
Positive.
V2, V3, because in the 3 direction, and this will be V3. Clear?
Yes, sir.
I see the like this, and this will be about 2, so this will be M2, and this will be M2, because this is my 2 axis, and I am having moment about 2 axis. So this is called a minor axis moments. So in case of minor axis, so SFD, if I want to see SFD, then I will go for V3, and BMD
M2.
M2. Okay. And what about axial force? You can see about 1 axis. So that will be, tension will be positive and compression will be negative. Clear? Yes or no?
Yes, sir.
Okay. Now we'll see the results, and then you will see how that is happening. Let's say,
एक्सक्यूज मी सर
yeah.
सर ये जो आपने बीम बताई है ये तो जैसे एक सिंगल एलिमेंट या सिंपली सपोर्टेड हो गया, अगर सर यही
नहीं
फिक्स्ड
नहीं
होगी तो सर
नहीं,
दोनों
सवाल वो
चीजें
नहीं है. It's a element. Now whether the end conditions, I have not talked anything about end conditions. End conditions may be simply supported, may be fixed, may be free,
सर
right?
वही पूछ रहा था कि
हाँ.
उस केस में तो ये साइन कन्वेंशन यही रहेगा या बदल जाएगा
Yes,
फिर,
yes.
जैसे
नहीं
अगर
नहीं नहीं
फिक्स्ड
नहीं
में
नहीं,
सर
सपोर्ट
जैसे
कंडीशन
फॉगिंग
से
और सैगिंग दोनों.
नहीं, सपोर्ट कंडीशन से फर्क नहीं पड़ता है. I will say that you just concentrate on uh, just concentrate on V2 and M3. Thank you.
Okay, sir.
Okay, so this is major shear force and this is major bending moment.
Yes, sir.
If you consider V3 and M2, then this is for minor shear force and minor bending moment, or bending moment about minor axis and shear force about minor axis. So most of the time, see, this is not at all required because we never design any beam for minor shear force. Now this M2 is not required in case of beams, but in case of columns, you need M2. So we'll see
Yes.
the column diagram separately. Okay.
Okay, sir.
For beam, you have to consider direction V2 and M3. Okay.
Okay, sir.
Yeah. Now let us see the bending moment diagram so that you will understand the concept more clear. Let us consider anything. Which frame you would like to see? Anything. 1, 2, 3, 4, A, B, C, D. I will open that and we'll see the bending moment and shear force diagram.
Anyone, sir.
Anyone. Let's go for 3. Okay. So I will go to elevation 3. So I will go to elevation 3. So I'm clicking on elevation 3. So this is my elevation 3 that you can see over here, elevation view 3, and you can see A, B, C, D and 3, 3, 3. That means it is a elevation 3. Now I will go to display and then I will go to force and stress diagram, and then here I will go to this frame, pier, spandrel or link forces. Click on it. Now he will ask you what you want. Either you may go for individual cases as dead load, live load, STL. So this will be available for all primary load cases. Okay. Then if you do not need a separate loading as per the primary load cases, you want to see the combination load cases, you will click over here. So combination load cases, you will see whatever load cases that you have defined. But right now you have defined only dead load and 1.5 dead load plus 1.5 live load. So that is available. Now out of that, you can select anything. Let's select the load case as 1.5 dead load plus 1.5 live load. Okay. Now here you will see you are directed to uh, say you have to define which one you want. Do you want to see the axial force? Yes, he will show you axial force. Do you want to see the torsion? Yes, he will show you the torsion. If you are interested to see the shear 2-2, he will see let you know the shear 2-2, or you may ask shear 3-3, moment 2-2, and moment 3-3. Now let us first consider shear 2-2 and click OK and see. This is the shear 2-2 uh, in your diagram. So you can see this is a major shear force, and forget about that whatever we have applied. So it is giving you right now. You can see it over here. So this is the standard. Now this red means negative and yellow means positive. And if I click on this, right click on this, and you will get this. So you can see that shear V2 because it is a major shear force. Clear? On left side, because of your loading and support conditions that you have defined, the analysis is saying that on left side, the shear is coming out to be 65.32 kilonewton. Then if you want to see, you can drag it. So at this point, you will see that at 4, a distance 4 from I end, you are getting almost zero. Graphically, you won't see exact zero because then that is accuracy. You have to put it like this. So you can see here 0.00. Okay. And if you go on right side, he is saying that on right side, you are getting shear force as 61.07. And if I draw it on this side, you will see that it is showing you negative. Okay. And on right side, it is showing you positive. Let us make a story for that. If I draw a beam, and here it is negative, that means it is upward, and here it is positive, that means it is upward, and you have applied a UDL. Clear? ऐसा है ना आपका?
Yes, sir.
जी सर.
And that's why it is showing you the diagram something like this. Now forget about this. This is something around 62, and this is something around 61. So it will depend as per your analysis. Anything may be okay, but the diagram, this diagram is showing you negative. That doesn't mean that you are having a shear force in this direction. Try to draw the sketch, and you will see what is making a problem. Let's see. Conventionally, if you say that positive is upward and here it is negative, that means it is downward, then you will see that this is not a stable condition. It is rotating. Yes or no?
Yes, sir.
It will start rotating
Yes, sir.
because you have drawn it incorrect way. Actually, this is negative, means on I end it is upward and not like this downward. तो ब्लाइंडली आप अगर अपवर्ड पॉजिटिव एंड डाउनवर्ड नेगेटिव हिसाब से ये डायग्राम निकालोगे, देन यू विल गेट कंफ्यूज्ड. क्लियर?
Yes, sir.
Now you can see this. If I right click on this, you will see that on right side it is 37.57 and on left side it is minus 28. That means both are acting upward. Clear?
Yes, sir.
So this is how you can predict the results. So here you have to choose the case, and this is I and J end. You must know the I and J end, and if you are looking for major shear, you should go for shear V2. Now let us see. I want to see the bending moment diagram. So I will go to display, post stress diagram, moment pier, and under that now I will select this M3 because major axis bending moment is M33. Major axis shear force is shear 22. Okay, clear?
Yes,
And
sir.
now you can see. Now, if you see this diagram, you will see that on both ends you are having a negative bending moment. That means I will say, see what I told you that. Okay, I said that I end if it is something like this. I end if you are having something like this, that means it is positive.
Positive.
And at J end, if you are having something like this, that means positive.
सर
Yes?
सर राइट हैंड लगाया ना हमें, राइट हैंड थंब रूल लगाया ना इसके अंदर.
See, I will say that this, if you find this element, let's say this is your bend, this beam. Now, if you say that the beam is deflected in a sagging direction, then you will have to apply a moment like this.
Yes, sir.
Yes, sir.
And if the beam is subjected to a moment which is a hogging moment, then you will see that you will have to apply a moment like this. So this is my positive moment and this is my negative moment. And you can see everywhere, see for this beam, I'm getting a red over here, a red over here. That means on this side, this is not correct. I'm having a moment something like this. On this side also, I'm having a moment like this. Clear?
Yes, sir.
Because in ETAP, or I will say in most of the softwares, tensile, the moments are drawn on tensile face. Are you getting it? नहीं हुआ, नहीं
आ गया
समझा ना?
सर, समझ
समझ
गए
में
सर।
आया कि नहीं आया?
सर वो अभी जो लास्ट वाला बोला वो समझ में
नहीं आया सर, समझ में, एक बार दोबारा क्लियर करवा दीजिए सर.
See, in any software, most of the time, the bending moments are drawn on tensile face. Tensile face. Why? Where you see in reinforced structure, if you want to provide a reinforcement, where you will provide? On
Tension
tension
side.
Tension side, tension face.
side.
Yes,
Okay.
sir.
Now, if I draw the bending moment on tension, see in your strength of material, what you used to say that this is your positive bending moment diagram. ऐसा ही था ना?
Yes sir.
Yes, sir.
This was your bending moment diagram negative. So anything below the axis, you used to say negative, and
Negative.
anything above the neutral axis or,
Positive.
or what positive. Actually, this is see conceptually you may say that क्योंकि see what I see left, you might see right if we are facing each other, right? जो मुझे 6 दिखाई दे रहा है क्योंकि आप और मैं सामने सामने बैठे हैं, जो मुझे 6 दिखाई दे रहा है वो आपको 9 दिखाई देगा क्योंकि हम अपोजिट एंड पर है ना. बट सी what so what I would like to express it. See in reinforced structures, the basic thing is that we want to provide a reinforcement on tension face. Okay. Yes or
Yes,
no?
sir.
Now let us consider this as your fixed end beam. This is your fixed end beam. Now I will draw it with depth. This is your fixed end beam. I'm having a depth of beam and width I'm not showing. So I'm drawing elevation. Now, due to the fixity, what is happening? If you are asked to draw the bending moment diagram, you will draw the bending moment diagrams as per your conventional thing, something like this. Yes or no?
Yes, sir.
Because you will say, sir, this is positive and this is negative. So hogging is negative and sagging is positive.
Positive.
ऐसा ही था ना आपका?
Yes, sir.
But this is the wrong idea. This is the wrong idea. See, if I draw, instead of this, if I draw a bending moment, something like this. And I call this as negative and this as positive. दोनों सेम ही है ना? बट यहां मुझे क्या हो रहा है, मुझे पता चल रहा है कि इतना रीजन में टेंशन इज एट बॉटम. and इतना region में tension is at top.
At top.
Clear?
Yes, sir.
That means I am drawing the bending moment diagram on tension phase, so that immediately I will understand this is my tension region. This is my tension region. This is my. So I will place a reinforcement somewhere here. I will place a reinforcement somewhere here. तो इससे ज्यादा कंसिस्टेंसी होगा ना इसमें.
Yes, sir.
ये डायग्राम का कंसिस्टेंसी अगर देखेंगे तो यू विल प्रोवाइड अ reinforcement over here, a reinforcement over here, and then reinforcement over here. So which will be exactly opposite. Actually, in this phase, you need a tension reinforcement at bottom while you are providing reinforcement at top. अगर ये follow करेंगे तो, because you will say that this is the region where you need to provide a tension. So draw it over here. Okay, let's draw the reflectors here so that you will understand it more clear. Let's say this is my bend, this is my beam. And if I want to see a deflected profile, then you can say that this will be something, deflected profile will be something like this. There will be, so it will be this much profile will have a tension on top, and this much profile, in this profile you will have a tension at bottom. Yes.
Yes, sir.
And that's why I will always draw a bending moment diagram like this and not like this. This is more preferable than this. I don't say this is wrong, but it is giving me some false idea about the physical conditions, right? So you can always draw a bending moment on tension phase. Clear?
Yes, sir.
Yes, sir.
That's why if you see this bending moment diagram, you will here itself you will say that, sir, in this region I need a reinforcement at bottom, and in this region I need a reinforcement at
At top.
Clear?
Yes, sir.
And now you can see, if I go to this, you will see that this is my negative bending moment, this is my negative bending moment, and this is my positive bending moment. And that's why I said that sagging moment is considered positive and hogging moment is considered negative. And you can check it over here. Clear?
Yes, sir.
Now let us go to any plan. Let's go to any plan. And you can check it, this diagram. You can see the bending moment is something like this. But is it correct? Yes. See, what do you think? This beam simply supported? Yes or no?
Yes, sir.
So that means if I draw the bending moment diagram, I should get a bending moment diagram like this and not like this. So actually, this diagram you are getting something like this.
Yes.
Why it happened?
क्योंकि सर वो थोड़ा सा उसके अंदर क्या बोलते हैं, थोड़ा सा
Partial fixity.
फिक्सिटी होती है,
but let
लिटिल
us
बिट
say
ऑफ
that
फिक्सिटी.
let us say that you want to make it okay, well, we'll think about this beam. Okay, if I see the bending moment diagram for this beam, let us see that. So I will go to that force stress diagram and frame pre-year, and let us go to M3, 1.5 dead load plus 1.5 live load, and you can see. And now if I right click, you will see that it is also showing some negative moment over here, some negative moment over here, and in between there is a positive bending moment. Actually, I don't need that because I want to design it as a simply supported beam. But the software is not considering that because we have not taken enough care to release the moment M3 on both ends while modeling the structure. Let's see, we'll see that. This is the first, okay. So the first story, and I will unlock it. And now after unlocking, if I want this as a simply support, how I can make it? See, I'm selecting it. So I have selected a beam. I have also selected this beam. I have also selected this beam, and I have also selected this beam. So all the beams, I don't want any moment at the end. I want to release the moment. Which moment I want to release? M2 or M3?
Which is major one? Major one.
So that means M3.
Yes, sir.
Yes, sir.
So after selecting that, I'm going to assign, click on assign, then I'm going to frame, and in frame, I will see somewhere here. Where is that? This release partial fixity. So I will click on it, and let's say that I want it M3 on both ends. So I want entire moment to get released. Clear?
Yes, sir.
Okay. So this is how the moment release is applied. Purposely, I have not done it before because I wanted to show you the results, and then I will show you how this moment will make change. Now, whether you want it or not, that is your decision. But if you decide to release the moment, I am showing you way how to release it. Clear?
Yes, sir.
Now, what about this beam? Would you like to release the moment over here and here? Yes or no? See, if you ask me, I will say that this is discontinuous end and this is continuous end. So I would like to release the moment on the J end only because I have drawn it from this to this. Okay. So I'm selecting the member. Again, I'm going to assign, and then I'm going to frame, and in frame,
Release.
I'm going to release partial fixity, and here I'm not releasing I end. You can see start. So I'm not releasing I end, I'm releasing J end. Clear?
Yes, sir.
Now this moment.
एक्सक्यूज मी
for
सर.
this beam, yeah.
सर जो आपने पहले की वीडियोस में, जैसे जो पिछला लेक्चर था सर, उसमें आपने एक बार ये बताया था ये चीज सर, उसमें आपने M22 और M33 दोनों रिलीज किए थे, तो सर इसमें जबकि M33 रिलीज किया तो सर उससे कोई डिफरेंस पड़ेगा
नहीं
क्या?
नहीं, उससे कुछ फर्क नहीं पड़ेगा बिकॉज यू आर नॉट गोइंग टू कंसिडर M2 व्हाइल यू आर डिजाइनिंग बीम. तो आपने रिलीज किया नहीं किया उससे कुछ फर्क नहीं पड़ता है. आपको चाहिए तो आप रिलीज कर सकते, आपको चाहिए तो आप रिलीज कर सकते, बट दैट इज नॉट रिक्वायर्ड.
ओके सर, वो पिछली वीडियो में था सर, इसलिए पूछ रहे थे
नहीं,
कि
वो पिछले वीडियो में मैंने आपको कैसे रिलीज कर सकते हैं वो बताया था.
हाँ हाँ.
मगर उसका इफेक्ट मैं यहाँ पे आपको बता रहा हूँ कि रिलीज किया तो क्या होगा और नहीं किया तो क्या होगा. तो पहले हमने देखा कि ना करने की वजह से एंड पर मोमेंट आया, राइट.
यस सर.
अब रिलीज करने की वजह से क्या होता है देख लेते. So I will release the moment at I end over this. So go to this and go to frame and release it and release the I end. Don't release the J end. Okay. So this is what I have done, and that has
Display.
been carried only at first slab or first floor slab. So we'll go and ask him to analyze. So we will run analysis. And the analysis will be carried. Okay. And then okay, this select and clear selection. So, and make it undeformed. Okay. And then I will click over here in this window, and now I will ask him to show me the bending moment diagram M33. So go to display, post trace diagram, member peer diagram, and here I will ask him M33 dead load and apply and close. And now you can see, if you go to this, yeah, M3, the moment over here is something like this. Why? Okay, let us see this. Here you can see exactly bending moment diagram, which is showing 0 over here. So if I go to this end, you can see 0. If I go to this end, you can see 0. Clear?
Yes, sir.
If I go to this, you will see that at I end, I have done 0, and at J end, you can see there is a negative
Minus.
bending moment.
Yes, sir.
Right? And now in this case, if I go to this, you can see at I end there is a moment, but at J end there is a 0.
No moment.
Right?
Yes, sir.
You can see this. So this is how you can create the thing. But let me know what is happening over here. So actually we have released the moment, but still it is carrying some moment over here. 19.27. That means if I click on this beam, it is having something. Check somewhere we have done something wrong, and that's why it is showing you. So if you go to this also, yeah, it is also showing you some. Yeah, it may be because of that partial loads that we have applied trapezoidal loads. So I think let me go to this and okay. So I will go to assign clear display of assign, and then if I click on that and loads, under loads there are no loads. Why? And on this, under loads there are no loads. I will have to check it. Something is wrong. Okay, go to display and go to force and member peer M33. Click OK. And if I go to this, see here also you are getting both moments 0. So that is how you can release the moment at ends, and then it will be subjected to uniformly distributed load with simply supported ends. Okay. I will check it why it is coming right now. Then we'll go for say columns. So I will go to say elevation 4. So if I go to elevation 4, you can go to elevation 4, and in elevation 4, first let us see the diagram. So here, if I go to axial force, and you will see that entire, so this is the red means it is negative. Okay, then let us go to assign, clear display of assign, and let me show you how the results for columns are shown. Okay, we'll draw the column. Okay, let us say this is my column.
सर
Yeah,
सर एक चीज पूछनी थी
हाँ बोलो बोलो.
सर, जो आपने मूवमेंट रिलीज किया था डिसकंटिन्यूअस एंड पे
हाँ,
और कंटिन्यूअस एंड पे मूवमेंट रिलीज नहीं किया था,
राइट.
तो उसका रीजन ये है कि अगर अपन कंटिन्यूअस एंड पे मूवमेंट रिलीज कर देंगे तो फोर्स अपना उस बीम में, आगे वाली बीम में ट्रांसफर ही नहीं हो पाएगा.
नहीं 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 नहीं. See what you are releasing. You are releasing moment. You are not releasing the force.
फोर्स,
So force तो
अच्छा
transfer होगा.
मूवमेंट नहीं हो पाएगा उसके अंदर.
Moment
फोर्स
नहीं
तो होगा
होगा.
लेकिन मूवमेंट ट्रांसफर नहीं हो पाएगा.
Yeah, yeah. That's why the moment coming at end is zero. See, this is your hinge. Okay,
यस सर.
this is your hinge, and this is your member. Let us say this is your member. See, if somebody is pushing this by a force P, you will see that it will deform.
ओके.
ये ऐसे deform होगा ना.
यस सर.
अगर ये आपने डिफॉर्मेशन रिस्ट्रेंड किया तो ही यहाँ पे मोमेंट आएगा. क्लियर?
यस सर.
See, again try to make it in a natural way. See, if you want to go anywhere and nobody is opposing you to go in that place. Let's say you want to go for swimming, and in your house nobody is saying that no you can't go. तो क्या होगा? आप सीधे जाएंगे ना.
यस सर.
स्ट्रेस क्रिएट होगा क्या?
नो सर.
नहीं होगा. मगर आपके बड़े भाई ने आपको बोला नहीं नहीं बच्चा तो अभी छोटा है, यू कैन नॉट गो टू स्विम. तो क्या होगा?
स्ट्रेस
There
क्रिएट
will
होगा.
be stress. There will be stress. There will be a reaction between you and your elder brother,
यस सर.
and result may be crying or maybe anything else, or you may start saying XYZ thing to him. He may say another XYZ thing to you. All that will happen because you are not allowed to do what you want to do. Yes.
यस सर.
So the reaction will come in place only when someone will restrain for the moment. Clear?
यस सर.
And if the movement is without any restraint, then it will start rotating. Yes or no?
यस सर.
Now let us consider.
हेलो.
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 हेलो हेलो. आई थिंक नेटवर्क नहीं मिल रहा सर को.
यस यस सर का नेटवर्क इशू है.
नेटवर्क का इशू आ गया. हेलो हेलो
सर लेफ्ट हो गए हैं।
उनका नेटवर्क इशू हो गया इसलिए लेफ्ट हो गया।
हाँ हाँ हाँ।
क्या करें फिर क्लास का?
देखते हैं, वेट करते हैं थोड़ा।
5-7 मिनट वेट करो फिर देखते हैं।
हाँ हाँ वही।
ये भी सही है।
Am I audible?
यस सर।
यस सर।
Yeah,
Yes, sir.
यस सर।
yeah, something suddenly it was disconnected. Let us see. Can you see this?
यस सर।
Okay. Uh, it was unfortunate. I don't know why. Okay. So we'll make it. Yes. So we were over here. Hello.
यस सर।
So this is, let's say this is your free cantilever. At free end, you are applying a load. Now, because of this, nobody is there to resist the downward movement, and that's why you will see, finally, you will see a deformation, something like this. So this will be deformation. Yes.
यस सर।
Yes. or no? But let us say the same beam you are having a hinge over here, and now you are applying a force. Then you will see a deformation, something in a different manner. So you will see it, and there will be reaction. Okay, so this will be R, and delta will be 0. Here delta will be something, but R will be 0, because there is no reaction. Free to move down. A reaction will come in picture only when it is restrained. The movement is restrained. So if your rotation is restrained, then you will see moment. If rotation is not restrained, you will see m equal to 0. Yes.
ओके सर।
So here there is a rotation. So you won't find any moment over here. So m will be 0.
सर
Yeah.
एक चीज पूछनी थी।
हम्म।
ये जैसे डिफ्लेक्टेड शेप में कई बार कंफ्यूजन होता है सर। यही वाला हिंज वाला जो एग्जांपल बताया ना आपने सेकंड, उसके अंदर अगर अपन जो एकदम हिंज के ऊपर से लोड डालेंगे तो वो वाली शेप अज्यूम नहीं करेगा ना। थोड़ा लेफ्ट में जाके लोड लगाना पड़ेगा, तब जाके वो शेप अज्यूम करेगा वैसी।
नहीं. See, if you are having a fixed end over here, and there is a hinge over here, and if you are applying exactly the same force over here, exactly you will get a reaction over here. So P and R will be same. But the deformation will be due to the self weight, or due to UDL, or due to any
Okay.
concentrated load or trapezoidal load, and that deformation you will see that it will be like this.
Okay. So this deformation is due to UDL and this point load, not P load.
Yeah. No, not P, because P is not going to rotate this. P
Yes,
is
sir.
directly applied at point. So
Okay,
you
sir.
will see that this.
Hmm.
Okay.
Okay, sir.
See
Yes.
this UDL, even if the UDL is not there, but the self weight is always there, no?
Yes, sir.
And that is why I said that in that case also you will find a rotation like this due to the UDL that is coming on behalf of the self weight of the beam.
Hmm.
Clear?
Yes, sir.
Yeah. Okay. Now we were trying to find out for columns. So let's say I'm having a column something like this. So this is my column. Okay. For the column, I will have always I at bottom and J at top by default. And you're drawing a column by just clicking a point. That's why he will consider I at bottom and J at top, and you will see this is your one axis. Okay.
Yes, sir.
And whether you are having a column rotation like this or like this, you will have a two axis in this direction and three axis in this direction. Okay. Similarly, I will say that this is my -1. So this is my +1. This is my -1, or you may say this is my -2,
2
and this is my
-3.
-3. Or you may say 3 axis, 2 axis, 1 axis. Now here we say that tension will be considered as positive and compression will be considered as
Negative.
so in your ETAB you will always find most of the time. There might be some cases where you will find column under tension, but most of the time, 99 out of 100 time, you will see that a column is subjected to compression, right? So
Yes, sir.
here you will get a negative magnitude,
Hmm.
and here also you will get negative magnitude, right? Are you getting it? Because
Yes, sir.
compression,
Yes, sir.
the column is subjected to compression most of the time, and
Hmm.
then it will be considered as negative, either at J end or at I end. Okay. Many times, if you follow a downward negative, and if you say at J end you are having a negative, that means it is acting downward, and at I end also you are getting negative, that means it is downward. Then you will see this is a movement. This is not a stable condition,
Hmm.
because you are not getting Fy, sigma Fy, or
Not 0.
sigma F1 not equal to 0. Clear? But
Sir,
actually, this is your concept. Concept is wrong. Actually, in ETAB, you will see this as negative. So both ends will show you negative sign, because we are considering compression negative and tension positive. Clear?
सर
Yes.
अपन सर वो जो आपने मेथड बताया था पॉजिटिव नेगेटिव नेगेटिव पॉजिटिव,
हाँ
वो वैसे भी कर सकते हैं ना अपन इसको?
हाँ, वैसे भी करो, वही आएगा. सी
जो +1 था वो पॉजिटिव था, और जो डायरेक्शन आपने डाउनवर्ड लगाया तो नेगेटिव था, प्लस माइनस माइनस हो गया.
right. See, this is I end and this is your J end, and on J end, positive axis is towards upward. So this is your plus, and if you are having at J end, if you are having a force in positive one action, so positive will be positive, but here you are getting results, you are getting like this. That's why it is negative.
हाँ सर.
Okay, and at I end, what is happening? That you are having a downward direction
-1.
negative, and if you are getting a force in this direction, then negative will be positive, but here you are getting force in this direction. That's why also it is negative. See, positive phase, positive direction will be shown positive. Okay, positive phase, negative direction will be said negative. Clear? You can see over here, a phase is positive, but direction is negative. So that's why negative. At negative end, negative phase, negative direction will be considered positive. Negative phase, positive
direction
will be considered negative. So your phase is negative, but direction is positive. So phase is negative, direction is positive, so negative. कैसे भी कर लो आप. Which one you should?
सर यही वाला मेथड सही है, जो ये यूनिवर्सल है जो आपने बताया, पॉजिटिव 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 नेगेटिव.
नहीं, वो सी रेफरेंस के साथ आप कुछ भी करो. जो आपको सुटेबल लगता है वो आप याद रखो, और जो आपको डिफिकल्ट लगता है उसे छोड़ दो. फाइनली रिजल्ट तो आपका वही आएगा. किसी को ये सूट करेगा. टेंशन will be positive, compression will be negative. ये दोनों आपको एक ही रिजल्ट देते हैं. Clear?
Yes sir.
So let us see the results now. So go to display, then go to force diagram, moment period diagram, and go for axial force and 1.5, and you will see. So everywhere you will see that let's see over here. See, this is negative. How much negative? You can check it over here. So axial force, how much?
767.8186
Okay.
kilonewton.
And if you check it over here, you are getting 782. So this is your I end, and this is your J end. And now the best way to check it, so consider this and consider dead load, and you will see this point. So due to dead load, you are getting 269.186, and here you are getting 278. That means there is a difference, but that difference is due to the self weight of this. Clear? So you can check the dimension and you can find out the weight density based on your cross section and length, and you will see that it is exactly matching. Clear?
Yes, sir.
Yeah, you can see this. You can check the dimension. How you will check the dimension? Because this software will always give you the bending moment and shear force diagram at the face. So at the face of column as well as at the face of beams. Okay, and here you will see that the zero starts from a floor below to bottom of the beam. So you can check the distance, then you multiply it with volume and density, you will get the force. And if you add the force into this, you will get a force over here. Clear? Or if I want to show you, let's say this is your column. So here you are getting a force from, so I will say P1. Okay, and this one, you will say that this is your weight. So you are getting this self weight as P2. And if you see this P3, if you call this as P3, you will find the equation as P1 plus P2 is equal to P3. ये इक्वेशन होना चाहिए कि नहीं?
Yes, sir.
But for that you have to go to dead load case, self weight. Otherwise then there will be a lot of other forces coming, then 1.5 and all that. You will see that you are not getting that correctly. But that doesn't mean that there is no equilibrium. Actually, if you want to see the equilibrium, you can check it here, because you just have to add self weight. So I will say that P2 is equal to self weight. Right?
Mhm.
Clear?
Yes, sir.
Or
Yes,
you can
sir.
check it. You can check it with other conditions also. But if you rightly place the law, you will get the equation correct. So this is how about columns. And now I will show you a little bit, see why some people get trapped in this. See, if you do not understand these basic concepts, and let us say you are displaying post-test diagram and member pair, and here let's say combination, and unfortunately you are going for M33. Okay,
So you have shear.
you will see that in bending in beams you are not getting any shear force, right?
Yes,
And
sir.
you might feel yourself that यार कुछ तो गड़बड़ हो गया, मेरा एनालिसिस करेक्ट नहीं है. आपका एनालिसिस करेक्ट हो सकता है, आपने डायग्राम करेक्ट नहीं चूज किया. तो गो टू डिस्प्ले, moment peer diagram, and this shear 33 is minor. And okay, let us go to moment 22 and see the bending moment in beams. Again, you will see there are no bending moment in beams, because you are checking it in incorrect manner. Clear?
Yes, sir.
ये बहुत बार लोगों के साथ होता है, because they don't understand what they are looking for. उनके दिमाग में shear force होता है, but उनको ऐसा लगता है कि shear 22 बराबर है. नहीं, shear 22 is minor axis shear, and shear shear 33 is minor axis shear. Shear 22 is major axis shear. And if you don't understand that, then the simple way is to draw the beam like this. Draw the beam immediately. Then you will draw the one axis something like this. You will draw two axis something like this, and then three axis something like this. So when you are going for V3, you are trying to find out the forces in this direction, right? And that's why
Yes,
you
sir.
don't see anything. Or even if you are going for checking M2, you're trying to find out moment about 2. So you are trying to find out moment about 2, and that's why you don't find moment about 2 in beams, right? Clear? तो अभी अभी कम से कम आपको ये कंफ्यूजन नहीं आएगा कि whether you want to see which one. So most of the time you will be checking for V2, M3,
M3.
and axial force, right? These are the 3 things that we are interested. Clear?
Yes, sir.
So with this, I will conclude today's session, and from next session, we'll directly go and find out the practical problem. We'll understand the architectural detailing first, then we'll create a model, and then we'll apply the loading with practical application of load. Now there we are not going to make any arbitrary loading. We will be calculating the loading based on architectural drawing and then apply it. Clear? And then
Then, sir,
yeah,
वो सर वो जो एक्चुअल साइट पे जो ड्राइंग्स होती है उसकी बात कर रहे हो आप?
yeah. वो प्रैक्टिकल भी देखना पड़ेगा ना. ये तो हमने पहले सी हियर इन जो भी हमने 3 या 4 सेशन लिए ना, शायद
5-6 ले लिए सर.
5 ले लिए सर, ये छठा है सर.
5 नहीं 5 हो
छठा
गए
है
होंगे,
सर ये.
4 या 5.
5 हो गए सर, 6 छठा है.
तो ये नहीं. तो 5 की हमने यहाँ पे क्या किया कि we created some imaginary structure with imaginary grid line, with imaginary sizing, with imaginary loading, but just we have concentrated on how to draw it. Now we will be going on practical problem. G+3 or G+5 will apply the all loading as per our Indian code 875 part 1, part 2, part 3. Then we'll apply the codal provision for IS 456. Then we'll go for lateral loading, and then we'll apply that static load as well as dynamic load, and then finally we'll go for high-rise structure. Clear?
Yes, sir.
Okay.
Yes, sir.
Yes.
I hope you people are enjoying everything.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
अगर कोई डाउट्स है जो आप क्लियर करना चाहते हैं तो यू कैन गो अहेड.
सर,
या
एक डाउट था फैक्टर ऑफ सेफ्टी पे.
बोलो.
सर, जैसे अपन जो स्ट्रेंथ है उसको डिवाइड एलएसएम मेथड में उसको डिवाइड करते हैं 1.5 से, और लोड को 1.5 से मल्टीप्लाई कर देते हैं.
राइट.
तो सर ये जो अपन साइट पे कैसे अचीव करते हैं इस चीज को? ये तो अपन
साइट पे-
थ्योरेटिकल देखते हैं कि
नहीं,
1.5
साइड पे ये कुछ करने की जरूरत नहीं. साइड पे वो आपने जो ड्राइंग दिया है वो ड्राइंग के हिसाब से वो काम करते. दे आर नॉट वरीड अबाउट 1.5 material strength and the load factor. They are not. So that is the design part.
सर उस डिजाइन में ही अपन क्या उसको अचीव करने के लिए क्या करते हैं जो डिजाइनर करते हैं उसके अंदर?
तो वही
स्ट्रक्चरल
किया
डिजाइनर.
ना. See, what we are doing, one way we are reducing the, we are going for strength reduction. See, when you are designing a structure, you are saying that factor of safety for concrete is 1.5 and for steel it is 1.5. That means you are dividing it by, for concrete, your whatever the strength of concrete, that you are dividing it by 1.5 and you are
Yes, sir.
using that much strength only,
Hmm.
right?
हाँ sir.
And you are dividing uh, a strength of reinforcement by 1.15
Hmm.
and you are using that lower strength because you don't want the material to reach its highest strength. So that is a factor of safety for material. Okay. Then load factor. Load. Why? What we are doing? Let's say if you are considering that okay, that due to live load, there will be a 2 kilonewton load coming on the structure. Then you are multiplying it by 1.5. That means you are designing your design load is coming out to be 3 and material strength is getting reduced and hence you are achieving your reserve capacity. So that is all taken care in the design formula.
तो सर वो डिजाइन में स्टील बढ़ा के देते होंगे उसको?
नहीं, डिजाइन में बढ़ाते कुछ नहीं. See, you are saying that 0.36 FCK
BXU.
B into XU. That is what you are counting as CU.
Yes sir.
Okay. And you are saying 0.87
FYST.
FY
AST.
into AST. That you are considering as TU.
Yes sir.
So इसी में वो सब आ गया.
अच्छा.
तो आगे कुछ करने की जरूरत नहीं. इसी में वो it has taken care of material strength as well as factor of safety for load.
ओके. इसमें ही मतलब सब कुछ आगे इंक्लूड कर दिया इसने.
Yeah.
जो भी.
So material strength is considered over here, and when you are finding out your moment design, there you are considering it as 1.5 times your moment working, and then you are equating it with CU into ZU or TU into ZU. See, calculation of CU or TU, यहाँ पे आपने फैक्टर ऑफ सेफ्टी फॉर मटेरियल अप्लाई किया और यहाँ पे आपने फैक्टर ऑफ सेफ्टी फॉर लोड अप्लाई किया.
Okay.
And then you are comparing this with this, and then whatever reinforcement that you are getting, that you are providing in the element, whether it is beam, column, etc.
Okay sir, now understood.
और उसके बावजूद साइट पर लोग क्या करते हैं, अरे नहीं वो क्या है, उन्होंने 216 डाल दिया, चलो हम एक बार एडिशनल डाल देंगे, तो वो ओवर रिएनफोर्स हो गया. आई मीन ओवर स्ट्रेंथ हो गया, नॉट ओवर रिएनफोर्स, दैट इज अ डिफरेंट कंसेप्ट. तो ज्यादा हो गया. तो यहाँ पे आपने वो सब केयर किया है तो एग्जैक्टली उतना ही दे दिया. इवन देन यू आर गेटिंग योर सेफ्टी अगेंस्ट कोलैप्स. बट साइड पे और लोग, वो होता है ना, हर कोई अपने हिसाब से उसमें ऐड करता है.
अब आगे सर मुझे समझ में, जो आपने मूवमेंट में 1.5 मल्टीप्लाई कर दिया और इधर ये एफसी के अपने आप घटा दिया इसको.
तो यहाँ पे आपने लोड फैक्टर अप्लाई किया.
हाँ.
और यहाँ पे आपने मटेरियल स्ट्रेंथ फैक्टर अप्लाई किया.
हाँ.
और दोनों को इक्वेट करने की वजह से जो स्टील आया वो आपने उधर कंसिडर किया.
यस सर.
सिंपल.
यस सर.
I will say that you may go through few books about reinforced concrete design. One may be that by Devdas Menon and Pillai.
Okay.
Dr. Devdas Menon, who is I think faculty chief in structure engineering at IIT Madras. आप उसको क्या हेड ऑफ द डिपार्टमेंट बोलते. So he is HOD at IIT Madras for structure engineering faculty. And nice books he has written. So you can go through that book. Or if you want to see a book from another, then I will say that Dr. S.R. Karve and Shah. And for you, if you people are interested in going through the books, we'll provide it on our classroom. You can download the soft copy and keep it for your library.
Yes sir, provide that sir.
वो तो नेट पे भी मिलता है. Okay, provide करते हैं, don't worry. Then one more thing I would like to say all of you that you might have heard about that that one website, that is what PaduEngineers.com. I think it is something as PaduEngineers.com. This is a site that is developed by the students from IIT Kharagpur, and this site will give you all civil engineering books. Actually, all faculty of structure, all faculty of engineering, they are providing the library. The only thing is that you have to go to this website, then you have to log in with your email and personal information, and it is free of cost. You don't have to pay anything. मगर आपको वहां पे लॉग इन करना पड़ता है. So you have to provide your data to that website. You can get all books regarding structure engineering on this website. But okay, we'll provide that for you on our classroom. Clear?
Yes sir.
और कुछ? मगर आप पढ़ेंगे कि नहीं पढ़ेंगे, क्या सिर्फ लेके रखेंगे?
नहीं सर, पढ़ेंगे.
हाँ, पढ़ना पड़ेगा. These are the nice books, and I will see that you will clear all your understanding about reinforced concrete design, particularly conforming to IS code. So everything about IS code and codal provisions is given into that. The provisions, they have explained why that what is the importance of that codal clause. So you can go through that. These are the two books I always ask everyone to refer. Okay, I think tomorrow I will ask my admin team to place it on your classroom. Yes. Anything else?
No sir.
Okay.
एक्सक्यूज मी सर.
Yeah.
सर जो आपने 2-3 स्टार्टिंग की क्लास में बताया था, जैसे हम ये बीम जब ड्रॉ करते हैं तो आपने बताया था बॉटम टू टॉप और लेफ्ट टू राइट बताया था आपने, जब हम ड्रॉ करते हैं ना IJ के कॉन्सेप्ट में. और सर जब आगे चल के हमने डायरेक्ट ही सेलेक्ट करके पूरी बीम एक ही प्लान पे बना दी, तो उस केस में सर वो IJ मैनुअली ले लेता है सॉफ्टवेयर, या फिर उस केस में कैसे हुआ सर?
Most of the time it will go from left to right for drawing beam parallel to x-axis, and bottom to top for beams parallel to y-axis, and for columns it will draw from bottom to top parallel to z-axis most of the time. But मान लो कि if you want to see that, that's a very nice question, and I must congratulate you for that, because I missed that point. Okay, I will show you that. Let us see. I will go to this. See, uh, this is that. And now if I want to see the I end and J end, or if I want to see the local axis system, I will go to view, then I will go to set display options, and in display options I will have to check it in object assignment, and in object assignment let me see this. So this is for shell assignment, and this is for frame assignment. Let us go for local axis for frame assignment, and apply and close. You can see this is red. uh, Red is your one axis, green is your two axis, and blue is your three axis. R, Z, and blue. Why so? Just go and see the American flag. I will say American flag. And in that case, you will see red color, green color, and blue color. So red is for top is red, that's why it is 1. Second is green, that's why it is 2, and blue is 3. And why American? Because this software is
Developed by Americans.
prepared in America. वो तो इंडियन फ्लैग थोड़ी ले लेंगे. अगर ये किसी इंडियन ने बनाया होता तो शायद वो इंडियन फ्लैग लेता. But this is a software that is prepared in California, that by Ashraf Habibullah and Wilson, Dr. Wilson, Ted Wilson, then Ray Clough. So these are the founders of this software, and they have used the colors as per their American flag. So you can see that. But try to see that everywhere you are having red in one direction only. Right? Blue in one direction, green in one direction. So ऐसा नहीं है कि कभी red right positive है, कभी see, this is about x-axis. Then what about y-axis? You can check it in elevation. So go to elevation and go to 3, and you can see. So everywhere parallel to x-axis, you see red, green upward, everywhere. Okay. So for beam,
Yes, sir.
okay, for beam. Then if you go for another elevation, let's say D, that is elevation parallel to that, you will see again same. Okay. And for columns, let us say if you want to see that in 3D, for columns you will see that your one axis is upward. Okay. Then your two axis, which is this, and three axis is this. Are you getting it?
Yes, sir.
So these are the local axis system apart from your global axis system. Even then here you can see that X red means it is 1, then green Y means 2, and Z blue means 3. Clear?
Yes, sir.
और अगर कंफ्यूजन है तो मैं आपको रेफरेंस दे ही दिया है. Just see the American flag and see which one is the top, which one is middle, and which one is bottom. इससे आसान तो कुछ नहीं होगा आपको. हाँ, अगर यहाँ पे आपको कुछ गलत दिखाई दे रहा है then you have to change it. Otherwise, and see why? Because see, for software, whether you are drawing from left to right or right to left is no problem. सॉफ्टवेयर वो सारी चीजें अपने दिमाग में रखेगा. सिर्फ वो रिजल्ट देते समय मान लो कि आपने यहां से बीम यहां पे लिया है and your one axis is something like this, then according your another axis will be like this. So this is your +1, this is your +2. So sometimes you are having this axis, sometimes you are having this axis.
Yes, sir.
So that will be problematic to understand the results. That is problematic to you, not to computer and not to software. सॉफ्टवेयर बोलेगा नहीं नहीं, ये बीम के लिए ये सही है, ये बीम के लिए ये सही है. आप कंफ्यूज हो जाएंगे इफ यू वांट टू इंटरप्रेट द रिजल्ट्स. वो बोलेगा नहीं नहीं सर, कुछ भी रिजल्ट देता है, कभी हाँ बोलता है, कभी ना बोलता है. That is not a problem of software. That is a problem for you. That's why I will always say, it's simple thing. When you are drawing a beam parallel to x-axis, draw it like this. When you are drawing beam parallel to y-axis, draw it like this. So this is positive, and this is positive. And why I am saying it this? Because you can see this is positive, and this is
Yes,
positive.
sir.
So I am following this. That's all.
नहीं सर, अगर जैसे मैनुअली जैसे आपने बताया था ना, ड्रॉ करते टाइम तो ऐसे कर लेंगे सर. अगर डायरेक्ट, अगर जैसे आपने बताया था कि हम पूरे प्लान को सेलेक्ट करके ऑटोमेटिक बीम हर जॉइंट से कनेक्ट हो जाएगी, तो उस केस में सर ये वाला कन्वेंशन फॉलो होगा या नहीं होगा, ये कंफ्यूजन थी.
नहीं, आप अगर इंपोर्ट कर रहे हैं ना, if you are creating all this framing in AutoCAD and then you are importing it in ETAB, then वहां पे आपने कैसे ड्रॉ किया है उसके ऊपर ये डिपेंड करता है.
ओके.
अगर आपने रेप्लिकेट कर रहे, मान लो आपने ग्राउंड फ्लोर पे या फर्स्ट फ्लोर पे आपने ड्रॉ किया और उसको आप रेप्लिकेट कर रहे अपर फ्लोर्स,
यस सर.
तो एग्जैक्टली वही कॉपी होगा अपर फ्लोर पे. मतलब जो गलती आपने फर्स्ट फ्लोर पे की वही गलती सारे फ्लोर पे हो जाएगी. अगर आपने गलती नहीं की, अगर आपने फर्स्ट फ्लोर पे कोई गलती नहीं की तो आपके ऊपर के सारे फ्लोर पे कोई गलती नहीं रहेगी.
यस सर.
या
तो जैसा नीचे वैसा ही ऊपर जाएगा सर.
या डेफिनेटली. ऊपर नीचे अगर आपका करेक्ट है तो ऊपर सब जगह करेक्ट रहेगा. एग्जैक्टली वही होगा.
यस सर.
या सॉफ्टवेयर डाटा रीड करने में कभी गलती नहीं करता है. हम लोग उसे, अगर हमारे आइडियाज क्लियर नहीं है और ऊपर ये टाइप का स्टडी किया है और कि कहीं आधा अधूरा सीख के काम कर रहे हैं, तो पता नहीं, अननोइंगली यू माइट बी क्रिएटिंग a wrong interpretation in your mind, but software cannot analyze that. तो सॉफ्टवेयर बोलेगा जो मुझे इंफॉर्मेशन मिली वो सही है.
यस सर.
एंड अगर आपको वो सारी चीजें, यू कैन डू इट ओवर हियर. गो टू दिस डॉक्यूमेंट्स, एंड इन डॉक्यूमेंट्स you can go to manuals, and in manuals you can go to analysis reference manual. You can click display and you will get everything. जो मैं आपको सिखा रहा हूँ वो सब यहां से सिखा रहा हूँ, मैंने यहां से सीखा है. And that's why I don't believe in something else, क्योंकि ये ओरिजिनल है, 100% ओरिजिनल है. ये आपको कोई लोग ये देखो जो मैंने आपको बताया था ना, ये यहाँ पे
यस
इंटरनल
सर,
फोर्स
यस।
आउटपुट, एग्जैक्टली। देखो ये वही मैं आपको दिखा रहा हूँ, क्लियर।
यस सर,
वो क्या
क्लियर
होता
सर,
है,
क्लियर।
या बाकी लोगों का और मुझ में इतना ही फर्क है कि मैं जो है जैसा है वैसे आपको बता रहा हूँ। बाकी लोग क्या करते, उसको घुमा फिरा के दिखाते और शो करते हैं कि वो कितने इंटेलिजेंट है। मुझे वो शो करने की जरूरत नहीं। मैं बोलता हूँ, मैं एक बंदा हूँ जो कॉपी करता हूँ। कहाँ से कॉपी किया है? ओरिजिनल से। और वो ओरिजिनल भी मैंने आपको दिखाया। यू कैन रीड इट, यू कैन रीड इट।
यस
सो दिस विल क्लियर ऑल योर डाउट्स। इसका नुकसान मेरे लिए इतना हो सकता है कि शायद आप बोलेंगे यार फिर मुझे अभी क्लास करने की जरूरत नहीं, मुझे सब यहाँ ही मिला है। कोई बात नहीं है, यू कैन रीड इट, बट दिस इज द बेस्ट थिंग दैट यू कैन गो थ्रू दैट। बट इट इज वेरी लेंथी। मुझे 2 साल लगे ये सब पढ़ने में। पता नहीं आपको कितने लगेंगे, पता नहीं, बट कंसिस्टेंटली मैं एवरी डे, ऑलमोस्ट एवरी डे 1 to 2 आवर्स ये सारे डॉक्यूमेंट्स पढ़ता था। और कुछ कुछ मैंने लिखा भी। उसके बाद मेरे समझ में आया, अरे इसका मीनिंग ऐसा है क्या। बहुत बहुत बड़ा है, बट इट्स ऑलवेज गुड। नॉट नेसेसरी दैट यू शुड रीड इट फॉर यू। जितना अब ये कंसेप्ट आपको कोई नहीं बताएगा, ये कार्डिनल पॉइंट्स। तो उसकी उसकी आगे चल के हम लोग देखेंगे वो। बट ये बहुत बहुत बड़ा है, बहुत बड़ा। तो शुरू में आपको 1 चैप्टर बाय 1 चैप्टर कर लो ना। ये देखो, ये दिस इज हाउ showing you joint
यस सर,
joint I joint, J joint, axis 1, axis 2, axis 3, plane 1 3।
यस सर, ये तो आज ही आपने पढ़ाया सर। यस सर।
या तो कहाँ से मैंने पढ़ा? ये यहाँ से। तो मैं आपको ओरिजिनल भी दे रहा हूँ। और शायद ये पढ़ने के बाद है ना, इनिशियली नहीं समझता। मुझे भी बहुत दिन लगे ये समझने में। ऐसे वो दैट डिपेंड्स थोड़ा। मगर एक है, इससे आपका अंडरस्टैंडिंग बहुत क्लियर होता है एंड विदाउट एनी डाउट। और अगर गलत भी हुआ ना, यू कैन करेक्ट इट इमीडिएटली, क्योंकि आपको उसी समय पता, अरे गलत हो गया। यू कैन डू इट। So this is the frame element. So you can go with joint element, frame element, degree of freedom, all these things.
यस सर।
ये आपको लोग बताएंगे नहीं, क्योंकि फिर उनका इम्पोर्टेंस खत्म होता है। या बहुत सारे लोगों को ये पता भी नहीं, आई डोंट नो। मगर मैं सबको बताता हूँ। जो सीखना चाहता है, मैं बोलता हूँ सीख ले बेटा, आगे आगे चल के काम आ जाएगा। ये देखो कोऑर्डिनेट सिस्टम कैसे कैसे डिफाइन किया है। व्हाट आर द बेसिक टॉपिक्स, व्हाट आर द एडवांस। राइट नाउ यू मे डिलीट दिस एडवांस टॉपिक। ये मत पढ़, मतलब बेसिक तो पढ़ लो।
ओके सर। यस सर।
या और थोड़ा बहुत अशरफ हबीबुल्ला और विल्सन, एडवर्ड विल्सन के बारे में भी थोड़ा देख लेंगे ना, पता चलेगा उन लोगों ने कितना काम किया है।
यस सर, ये तो है।
क्या होता है, पता नहीं होने से ना हमें ऐसा लगता है कि यार मुझे सब आता है। अब बहुत सारी चीजें यू कैन सी हाउ मेनी पेजेस आर देयर। बहुत इफ आई गो एंड शो यू दैट
इट्स
536
ऑलमोस्ट 536। यस।
तो अगर आपने एक पेज रोज भी पढ़ा ना, तो ज्यादा 535 डेज में पूरा हो जाएगा ना। ये तो
रोज से ज्यादा ही पढ़ लेंगे सर, अभी तो टाइम
नहीं
है।
नहीं नहीं, ये देखो ये एडवर्ड विल्सन,
यस सर।
ये फाउंडर है। ये हशरफ हबीबुल्लाह के ये, और ये बुक मैं आपको कहूंगा, इफ यू गो विद दिस बुक, three dimensional dynamic analysis of structures with emphasis on earthquake engineering by Edward Wilson. देख लो अगर कहीं मिलता है तो।
यस सर, आई विल सर्च ऑन इंटरनेट।
बहुत सारा ये एडवर्ड विल्सन का इतना इतना सब कुछ है ना, यूनिवर्सिटी ऑफ कैलिफोर्निया बर्कली, और ये लोग है ओरिजिनेटर, इनकी वजह से सारी दुनिया आज आगे है। तो वी शुड थैंक ऑल ऑफ टू देम, क्योंकि उनकी वजह से हम लोग हाई राइज स्ट्रक्चर्स में काम कर रहे हैं।
यस सर।
Then you can go for this also. A.K. Gupta, he is also this is for response spectrum method in seismic analysis and design of structures. यहाँ पे सारी चीजें है। You can, if you want to understand finite element, this is K.J. Beth. He is the, I will say he is the pioneer of this, because he started in 1982, so he was doing everything in there. So again, see KJ Beth and Edward Wilson. You will find Edward Wilson everywhere. Anyway,
yes, sir.
so this is all those who are more interested in going through this. So कहाँ से जाना है आपको? See, help, documentation. Under documentation, you will go to manuals, and under manual you will click analysis reference manual, and then you will click display, and
yes, sir.
it will be for you. अब इतना काम करने के बावजूद उन्होंने ये सबके लिए रखा है, तो मैया आप कौन होते हैं लोगों को रोकने को, ये ना दिखाने को? जो मालिक है उन्होंने सबके लिए रखा है, और हम लोग उसको ताला लगा के बोलते हैं नहीं नहीं उसको नहीं देगा, उसको नहीं देगा। समझ में आया ना?
यस सर, आ गया।
जो मालिक है उन्होंने खोल के रखा है पूरी दुनिया के लिए, कोई भी आओ और यहाँ देख लो, और हम लोग बोलते हैं नहीं नहीं उसको नहीं देंगे, नहीं तो वो आगे जाएगा। अरे उसको आगे जाना है तो वो जाने ही वाला है, तुम्हारे रोकने से थोड़ी रुकने वाला है। Yes, so this is how
Yes.
we are working, and I think you people will keep that with you कि जितना आपके पास है, जितने ज्यादा से ज्यादा लोगों को दे सकते हैं दे दो, क्योंकि देने से आपका कम नहीं होने वाला। Okay, then with this we'll conclude today's session, and I think now day after tomorrow we'll start with practical problem.
Yes, sir.
Okay.
Good night.
Thank you, sir.
Good night. Thank you.
Thank you,
Good night.
Professor.
Yeah.